Here we are going to start off by noticing that with integration, we need to go from two trig functions to one trig function. So this is just one trig function. It is not going to become some secant squared thing. There is not a formula for that unless you have memorized that natural log formula for a tangent, but you are not required to do that for this Calc 1 class. So knowing that there's not an integral rule, that's our first step. Is there an integral rule? There isn't one. So then you go and you say, okay, well, maybe I can simplify it. There isn't really any simplification. So then you say, well, maybe I can use substitution. So usually what we do for substitution is we pick the quantity in parentheses. So let's just kind of blindly roll with that and say that we're going to pick u, the quantity in parentheses, as 2x, and then our du will be equal to 2 dx. Okay? So with that u and du definition, let's see if we are able to solve this. So first thing, I'll look at my u and say that all of this 2x business is going to become a u. So this will leave me with tangent of u dx. Now if I look at my du definition, I see that I need to multiply n by a 2 to get du. So if I multiply n by a 2 to get the 2 dx, I have to divide by a 2 to balance that out. So that's going to give us 1/2 integral. Tangent of u is still there, and then du is coming from this 2 dx. Now, at this point, it's like, okay, I don't have an integral rule for tangent of u. So here is where I try to simplify this, and I simplify it the same way I simplified it in trig with those trig identities, and I convert this into sine of u over cosine of u. Okay. Now, we talked about this before when we had to integrate tangent of x, but I want to go through this again. So you need that the u function and its derivative appear inside of the integral. And I said if there's ever like a big toss-up, like I don't know, should I choose the denominator, should I choose the numerator, always pick the denominator. So we are going to pick for our u cosine of u. Now that doesn't make any sense if you're talking about u is equal to cosine of u. So keep in mind that this is our second substitution, and so because it's our second substitution, we need another variable. Sometimes we'll call it that w. So I'll set w to be cosine of u. But you can't be talking about u over here and u over here. It has to be a different letter for your second substitution. All right, so let me rewrite this. So w is equal to cosine of u. So dw, when you differentiate cosine, you get a negative. So negative sine of u du. All right, so let's see if we can make that happen. All right, so we start with w. This cosine of u in the denominator is going to become w. So that's going to leave us with the goal of integrating sine of u over w du. Then we go to our dw and we say, okay, we don't have a negative, so let's multiply in by that needed negative and then balance it by multiplying outside by the negative. And then we have the sine and we have the du. So all of that numerator is going to become our dw. And then it's over w, integrate negative 1 over 2. Now, hopefully you are getting pretty good at this and you can recognize that this is natural log. If you do not recognize that, just keep in mind that if you move it up into the numerator, then when you add 1, divide by the new exponent, you get a big old 0 in the denominator. And that's what tells you that you're talking about a natural log. So this will be 1 over w, so that's going to give us natural log, absolute value of w. The negative 1/2 carries along, and then plus c because we do not have bounds. Now, we are not done because we have to substitute back. So we went through the integration and we finally integrated. So going from here to here, that is my integration step. And then going from here to here, I'm going to substitute back. All right, so first I substitute in what my w is. So I have negative 1/2 natural log absolute value. W is cosine of u plus c. Then I substitute in what my u is, and that I have to go way back up here to the top of the problem, and u is equal to 2x. So this is cosine parentheses 2x plus c. And now we're back in terms of the original variable, so that is our final answer.